Welcome to our channel. Today we're diving into the heart of our solar system with 10 mind-blowing facts about the sun. This celestial wonder, our very own star, is more than just a source of light and warmth. It's a churning cauldron of nuclear fire, a magnetic maestro, and the anchor around which our entire planetary system dances. Let's pull back the curtain on this cosmic powerhouse and uncover the secrets it holds. From its immense energy output to its surprising color, get ready to have your mind blown, because we're about to embark on a journey to understand the true nature of our very own star. Let's get started. The sun, this seemingly serene object in our sky, is anything but calm. It's a cosmic powerhouse, a giant ball of plasma held together by its own immense gravity. And that gravity is something to behold. The sun accounts for a staggering 99.8% of the entire solar system's mass. That means all the planets, asteroids, comets, even you and I, amount to a mere fraction of the sun's total heft. But the sun's influence goes far beyond its gravitational pull. Deep within its core, a nuclear furnace rages, converting 620 million tons of hydrogen into helium every single second. Imagine the power of 1 billion nuclear bombs detonating simultaneously. That's the energy the sun produces each and every moment. It's this energy that bathes our planet in light and warmth, making life as we know it possible. We often depict the sun as a cheerful yellow orb, and who can blame us? That's how it appears in our sky, but here's a surprise. The sun isn't actually yellow, it's white. The yellow hue we perceive is a trick of the light, a result of our atmosphere scattering sunlight, particularly the shorter blue wavelengths. The sun's surface, known as the photosphere, burns at a scorching 5,500 degrees Celsius. That's hot enough to melt any known metal, but that's nothing compared to the core, where temperatures reach a mind-boggling 15 million degrees Celsius. At these extreme temperatures, matter exists in a state of plasma, where electrons are stripped from atoms, creating a chaotic sea of charged particles. We often say that sunlight takes about 8 minutes to reach Earth, traveling at the speed of light, of course. But that journey, from the sun's core to its surface and then to us, is far more complex than it seems. The energy generated in the sun's core today won't actually reach its surface for another 100,000 years. This is because the energy generated in the core must first navigate a dense and chaotic region known as the radiative zone. Here, photons of light are constantly absorbed and re-emitted by atoms, bouncing around in a cosmic pinball machine for millennia before finally breaking free. It's a testament to the immense scale and complexity of our star. The sun may be our life-giver, but it's not always a benevolent neighbor. Our star has a temper, capable of unleashing powerful solar storms that can wreak havoc on our technology-dependent world. These storms come in the form of solar flares and coronal mass ejections, or CMEs. Imagine billions of tons of charged particles, a superheated plasma blasting from the sun's atmosphere and hurtling through space at millions of miles per hour. These solar storms can disrupt satellite communications, knock out power grids, and even pose a radiation hazard to astronauts. In 1859, the Carrington event, the largest solar storm ever recorded, caused auroras to be seen as far south as the Caribbean and fried telegraph systems worldwide, a stark reminder of the sun's raw power. The sun is a giant ball of plasma, and like any plasma, it's heavily influenced by magnetism. In fact, the sun possesses a powerful magnetic field that stretches far beyond its visible surface, creating a region known as the heliosphere. But here's the fascinating part: this magnetic field isn't static. It flips polarity approximately every 11 years, in a cycle known as the solar cycle. This flip-flop has a profound impact on the sun's activity. Sunspots, those dark, cooler regions on the sun's surface, are linked to intense magnetic activity. These sunspots can grow larger than Earth itself, and their number and intensity wax and wane with the solar cycle. Understanding this magnetic dance is key to predicting solar storms and their potential impact on Earth. The sun isn't just a giant ball of fire. It's also constantly shedding its outer layers in a stream of charged particles known as the solar wind. This wind, a constant flow of protons and electrons, blows through the solar system at speeds of over 1 million miles per hour, bathing everything in its path. When the solar wind interacts with Earth's magnetic field, something magical happens. The charged particles are channeled towards our planet's poles, where they collide with atoms in the atmosphere, exciting them and causing them to glow. This is the origin of the breathtaking auroras, also known as the Northern and Southern Lights, a celestial ballet of light that has captivated humanity for millennia. Now you might think that as you move further away from a heat source, things get cooler, right? Well, the sun likes to defy expectations. The sun's outer atmosphere, known as the corona, is a region of intense heat, reaching temperatures of millions of degrees Celsius. That's hundreds of times hotter than the sun's surface. This discrepancy, known as the coronal heating problem, has puzzled scientists for decades. How can the corona be so much hotter than the surface it surrounds? Current theories suggest that magnetic waves and tiny explosions called nanoflares might be transporting energy from the sun's interior to the corona, but the exact mechanism remains one of the biggest mysteries in solar physics. The sun, our constant companion, won't be around forever. Like all stars, it has a life cycle, and we're currently witnessing it in its prime. But in about 5 billion years, the sun will begin to run out of its hydrogen fuel. As the core contracts and heats up, the outer layers will expand dramatically, transforming the sun into a red giant. This expansion will be catastrophic for the inner solar system. Mercury and Venus will be engulfed by the expanding sun, and Earth's fate remains uncertain. Eventually, after shedding its outer layers, the sun will shrink down to a dense, Earth-sized ember known as a white dwarf, a stellar corpse that will slowly cool over billions of years. A sobering reminder that even stars have a lifespan. The sun isn't silent, it vibrates and resonates, producing sound waves that travel through its interior. These waves, generated by the turbulent convection beneath the sun's surface, are far too low for us to hear, but scientists can detect them by observing the subtle oscillations of the sun's surface. This field of study, known as helioseismology, is similar to how geologists use earthquakes to study Earth's interior. By analyzing these solar sound waves, scientists can map the sun's internal structure, study its rotation, and even detect sunspots on the far side of the sun that would otherwise be invisible to us. The sun may be the center of our solar system, but it's not stationary. Our entire solar system is hurtling through space, orbiting the center of the Milky Way galaxy at a staggering speed of 447,000 miles per hour. That's fast enough to travel from Earth to the Moon in just over an hour. This galactic journey takes us through a constantly changing interstellar environment. Currently, we're passing through a region known as the local interstellar cloud, a relatively sparse collection of gas and dust. As we continue our voyage, we'll encounter denser regions, which could have a significant impact on our planet's climate and evolution. Thanks for watching. If you enjoyed these mind-blowing facts about the sun, don't forget to like, subscribe, and hit the bell icon for more amazing content. See you next time. From its immense energy output to its surprising color and hidden depths, the sun continues to captivate and inspire us. It's a reminder of the vastness and wonder of the cosmos, and the intricate ways in which we are connected to the universe around us. Until next time, keep looking up and marveling at the celestial wonders that grace our skies.